In this video we will finish an algorithm to calculate the value of B1 from a known reflection pattern. A little bit flashback, the pictures here show a pattern simplification process from T over S equals 3 over 10 to T primed over S primed equals 2 over 3. It's done by ignoring reflection points beyond the first one, and then continued by reconnecting its ends. When the pattern is simple enough, the values of C1 and B1 can be easily determined. They can then be used to calculate the values of C1 and B1 of the original pattern. The process can be written in the table. In case of C1 and B1 of the simplified pattern can't be determined yet, the pattern can be simplified further. The arrows show the sequence of the process to calculate B1 of the original pattern. In the sample above, T over S equals 34 over 89. S of first simplified pattern is T of original pattern, which equals 34. T of first simplified pattern is T subtracted by S mod T, of original pattern, which is 34 subtracted by 89 mod 34, which equals 34 minus 21, which equals 13. The value of B1 and C1 cannot be determined yet, hence the simplification process needs to continue. S of second simplified pattern equals T of first simplified pattern, which is 13. T of second simplified pattern equals T subtracted by S mod T, of first simplified pattern, which equals 13 subtracted by 34 mod 13, which equals 13 minus 8, which equals 5. The process can be continued to get even simpler pattern. In third simplified pattern, T over S equals 2 over 5. In fourth simplified pattern, T over S equals 1 over 2. When T has been reduced to 1, the value of C1 and B1 can be determined right away, which are 0 and 1, respectively. The next steps are to calculate the value of C1 and B1 of the less simplified pattern, up to the original pattern. C1 in third simplified pattern is B1 in fourth simplified pattern. Here, it's 1. B1 in third simplified pattern can be calculated using formula B1 equals C1 times S plus 1 divided by T. Here, it's 1 times 5 plus 1, then divided by 2. It equals 6 divided by 2, which equals 3. C1 in second simplified pattern is 3. B1 in second simplified pattern is 3 times 13 plus 1, divided by 5. It equals 40 over 5, which equals 8. C1 in first simplified pattern is 8. B1 in first simplified pattern is 8 times 34 plus 1, divided by 13. It equals 273 over 13, which equals 21. C1 in original pattern is 21. B1 in original pattern is 21 times 89 plus 1, divided by 34. It equals 1870 over 34, which equals 55. The value of B1 can be used to calculate the number of reflection required to reach any reflection point by formula BA equals B1 times T, mod S. We can see some redundancy of numbers in the table above. They can be removed to get simpler writing form. In the simplified form, right arrows show operation T primed equals T subtracted by S mod T, with T primed shows cell content on the right side of the arrow. T shows cell content on the left side of the arrow. S shows cell content on the left side of the cell containing T. Left arrows show operation B1 equals C1 times S plus 1 divided by T, with B1 shows cell content on the left side of the arrow. C1 shows cell content on the right side of the arrow. S shows cell content on the top left corner of the arrow. T shows cell content on the top right corner of the arrow. The simplification method here can be called positive type, because the process is always done in the same direction as the original pattern.